Hi, I'm Jasak from Yonsei University, and I'm gonna present our paper, StyleKeeper. Our task is as follows. Let's assume user provide the reference style image such as cloud or tutorial here. When the user desires to generate new content like Pegasus or Eiffel Tower, our goal is to reflect the style elements depicted in the reference style image. It is called visual style prompting. However, there is a challenge. Let's create a dinosaur images using a horse image as a reference style image. Existing methods seem to work pretty well. They all generate dinosaur images while reflecting the style of the reference image. However, if we try to generate more images from various random noise, problems arise. Despite being generated with different random sets, all dinosaurs are aligned in the same direction as the horse, facing left side. In addition, they all have these silly horse-like legs. I've never seen this kind of mixed creature in the science book before. We call this problem as content leakage, where undesired visual elements transferred along with the intended style. Here, our StyleKeeper addresses the content leakage. It only reflects the desired style in the reference image while faithfully render various dinosaurs. In addition, ours is training-free, allows a real image as a reference, and well compatible with existing methods. Let's see how our StyleKeeper works. Let's start with a brief overview. This diagram illustrates the four key components of our approach, which enables precise style transfer without content leakage. Using stochastic encoding, we first encode the reference image into a latent, from which style elements are extracted. Then, the latent is fed into pre-trained diffusion models and used as a source of a swapping self-attention mechanism, which allows us to reflect the reference image's style by swapping the key and the value features from the reference image into the original generation process. At the same time, our negative visual query guidance prevents undesired content from the reference leaking into the resulting image. It ensures that the generated image better aligns with the text prompt. Finally, color calibration enhances the output visual quality. It adjusts the color distribution of the generated image to match that of the reference, ensuring a consistent and visually appealing result. Together, these components work seamlessly to produce high-quality output, reflecting style and content specified by the user. StyleKeeper is efficient and adaptable to different text-to-image and image-to-image scenarios. Now, let's start from how the style element in the reference image is transferred into original denoising process using swapping self-attention. For swapping self-attention, first prepares the reference denoising process through stochastic encoding, which maps the reference image X0 visual into a XT visual. If ready, swap the key value of the original denoising process from those of the reference denoising process. In the classifier-free guidance equation shown at the bottom, the purple term represents the step where we swap the key and value in the self-attention layers. Key value swapping is performed only in the upblocks final layers, where global high-level style features are represented. This operation reflects the style of the reference image and is critical for transferring style effectively. Despite of using those selective layers, the key value do not transform only style elements, but also content elements. So it might cause content leakage. To address the problem, we introduce a negative visual query guidance. Let's focus on the green term in the classifier-free guidance equation. This term corresponds to the negative text prompt, which is traditionally used to specify text elements that should not appear in the generated image. In the context of visual style prompting, You extend the negative text prompt concept to the feature level by specifying content features that should not be excluded. In the self-attention mechanism, key and value encode style, while query represents content. Therefore, to prevent undesired content from the reference image from appearing in the output, we swap the query in the self-attention layers. This is why we call this technique negative visual query guidance. This query swapping step is applied in all self-attention layers except for those where key value swapping has already been performed. After performing the key value and query swapping, we combine the result. The combined representation is marked in orange as XT original, which reflects the contributions from both the swapping operations. By combining these steps, our method effectively controls both the style and content of the generated image without content leakage. Next, let's see our strategies for using real image as a reference, stochastic encoding, and color calibration. The stochastic encoding maps the reference image into the latent space in a way that aligns with the diffusion model's process. As shown on the left, we take the reference image X0 reference and add the Gaussian noise epsilon using the same formula as the forward process in diffusion models during training. This step ensures the style from the reference is encoded correctly without causing artifacts. On the right, you can see a comparison with DDIM inversion. Stochastic encoding reduces artifacts and aligns better with the reference style. Combined with color calibration, it further enhances the result as shown in the bottom row. The graph B shows that stochastic encoding better matches the standard Gaussian distribution, enabling more accurate and reliable results in tasks that use reference images as visual style prompts. In short, stochastic encoding is a simple but effective way to prepare the reference image for high-quality style transfer. Now let's see the effectiveness of CFG and negative visual query guidance, named NVQG, along with our analysis of self-attention layers. As shown on the left, applying CFG and NVQG reserve artifact and stop content leakage. The third row shows that NVQG have the generated images better aligned with the text prompt, while reflecting the desired style from the reference image. On the right, we analyze how swapping at different self-attention layers impacts the output. Through the analysis, we found the optimal layers, yellow star, in the figure, where StyleKeeper shows best balance between style and content in the generated output. This figure compares our method with existing method in the task of style transfer with the reference image for a text-to-image scenario. Across all examples, our method clearly outperforms the others in three key aspects. First, style fidelity. Our result reflects the reference styles more accurately than other methods. Second, content alignment. The generated images align closely with the text prompts without introducing unintended elements, avoiding content leakage. Third, robustness. Our method performs consistently across diverse styles such as clouds, flames, and artistic strokes. In short, our method achieves superior style transfer while faithfully preserving the content specified in the text prompt, making it more reliable than existing approaches. StyleKeeper also works for image-to-image style transfer by combining ControlNet. This figure compares our method with existing image-to-image approaches, where both a content image and a reference style image are provided. Ours produces the most reliable and high-quality results across diverse styles and input. This figure demonstrated the effectiveness of our method in handling both simple and complex text prompts. while maintaining key strengths. On the left, for simple prompts like giraffe, lion, or moose, our method accurately reflects the reference style while showing diverse layout composition within the same text prompt. It shows that StyleKeeper does not suffer content leakage. On the right, for complex prompts like detailed scene, our method effectively combines the style of the reference image with the nuanced details of the text prompt. In conclusion, our method consistently captures the essence of the text prompt and the style of the reference image while avoiding content leakage and producing diverse high-quality results. For more details and results, please refer to our paper in code. Thanks for watching.